Hello everyone, welcome back to my channel. In the previous video, we have seen how to declare a output pin in STM32, like enabling the pin, making the mode to the input pin, out pin, and for that output pin, we have connected an LED and we made a toggling using. Now, today, we will go with another topic, that is the input pin. Today we are going to talk about one of the simple but most important input devices in embedded system, the switches. In this video, I will explain what switch is, how it works inside the STM32 with pull-up register, and finally we are going to connect a switch and an LED and declare them as an input output and see how the operation goes on. In my STM Nucleo board, I have a inbuilt push button switch. This is in blue color. We have also another switch in a black. This is a reset pin. But this blue color switch is a user input switch. Using this inbuilt switch, we are going to see how the operation goes. In this Nucleo datasheet, you can find a topic called push button. In this, B1 is a user push button. This is functionally defaultly connected to PC13 in my Nucleo board. And when this button is depressed, this gets the logic state to 1, otherwise it will be the 0. This means this push button is connected in the pull-up register format. Now, before we have declared for a PA pin, now we need to go with the PC13. Means first I need to enable PC register. In the user manual, we will find the enable clock register pin. You can find GPIOC enable pin here. First, let's enable this pin. That is see, this is to enable the GPIO pin. Next, we go with the modder pin. Now when I want to connect the GPIO modder, we know that this is PC0, PC1, so on, and this will be PC15. Our pin is connected to PC13. It means bit 27 and 26 need to be enabled. Now, to work this 2-bit as an input, we need to declare them as a 0 0, means a input mode. So to declare make them this as a 0 0, let's only clear this bit so it will work as a input pin for us. This will make my PC13 as 00 and make it to operate as the input pin, like 2 into 13 means a 26. 13 I am using because PC13, the pin 13 represents this, 2 because each pin has a 2 bits in it. So initially 1 1 will need to be shifted for the 26 times. So 2 into 13 makes me easily understandable. Now let's declare the input pin. Before, for the output, we have seen the GPIOX ODR as an output data register, but GPIO port input data register will be IDR. Here, this will be PC0, this will be PC15, and this bit 13 will be PC13. From this pin, I need to read whether this bit is 0 or 1. Other than all these bits, I need not to concentrate on that. So, in the inbuilt, to make you understand clearly when more number of switches are connected, we will make a one thing. The inbuilt switch is PC13. We will connect an external switch for PC12. Also, let's connect an PC12 also to this register. It means this port now 13 and 12 will act as a switch. Let's assume it like that. Now let's declare the input. And as I told, now PC 13 and 12 I'm using as a switch. For this, to read, leave this, we all need to read it as a 0 when the PC13 gets 1. Other all zeros, it means this will be as 2. So when switch 1 is pressed, we need to read it as 0000 to 000. It means when 2 is pressed, this will be the hexadecimal to read. Same, if PC12 has been pressed, this becomes 1. So at that time, it reads 1 here. This will be the method to read the switches now when it is pressed. Now let's make a function like to detect the switch is pressed. I will call a variable long int detect switch. Now let's call on a function to read which key is pressed. So for that I will call read SW pressed. Let's take the function here. I have just changed the names. Now let's call the functions. Unsigned long. This will return this type. Read switch pressed. Now what is need to do with this function? Now see, the condition now in while loop goes like if SW pressed, if it is equals to SW1, it means after detecting the switch in this function, if the key press is equals to the switch 1 in this condition, it means it detects that SW1 is pressed. At that time, what I'm going to do is I will turn on the LED. This will make to turn on my LED. Same when the switch is not pressed. At that time, I don't want to turn on my LED. It should be in the off state. This will make my LED off state. Now I don't require this. Let's comment it. Now in the function to detect what has been pressed, what we are going to do here is in this input we need to read. Now I told you that PC13 and 12 has been as a switch connected and I need to read this pin. So what I do is I will send bit 1 and 1 and make this logical shift to move towards left for 12 times and bring this 1 and 1 here by making the logical shift left. Then how to detect this now? We will make an AND operation with the input which will be read by here. If here it has been 1 and operation with 1, others all will be in the 0. At that time it will be 1 and 1 will be 1, others all remain in the 0, so that we can detect that PC13 is pressed. Same with the PC12. When PC12 becomes 1 and by the logical shift here we have an 1, other all the pins will be 0 when 1 and 1 has been detected by the logical operation becomes 1, others all will remain 0. We can detect PC12 has been depressed. So return IOC IDR and operation with 3 and shift by 12. That's it. This will make work comfortably. Let's dump the code and check the output once. I need to add here. Okay, this is working fine. I will share the video. You can check it out there. That video you might have seen how when I press the switch, the LED is turning on and I release the switch, it is getting off. What does this mean is the LED, the switch is working in the mode which is called as level trigger. This is working fine for the level trigger. But what if I want to work the switch as a state trigger? For that, we need to make few changes in this code itself. How? Let's make a function that is we got to know that when switch is pressed it will be this hexadecimal, and when switch 2 is pressed this will be the condition. Same this is all released when switch is not pressed at that condition. This should be in this state. All are zeros. Why it is useful means I will show you here. Now let's add two other micros, that is this is for the level trigger, this is for the state trigger. Now in this part we need to decide in which condition I need to work the switch. Suppose if I write here level, then this push button should work in the level trigger, and in this function make a changes here, that is 2 unsigned char is enough for us because this level is just of 0 or 1. Let's take this as a mode. Now if mode equals to level trigger, then we have seen that this condition was working fine for us for the level condition. So let's declare this one. Now for the state, we change the mode equals to, if it is state, then what we need to do, once in the state, when switch is pressed once, it means it gets detected and there should be no change in the conditions. So let's comment this. For that, what condition I will do is, when the switch is detected, at that time LED will toggle. Means when I press the switch one time, it will get on. When I press it again, it get turned off. Here in the both the condition, you can make the differences. This is level trigger. When we press the switch, at that time only the light will be on. As we released, it get turned off. But in the state, if I press once and leave, it will be on itself. And if I press again, it get turns off. For this, I'm going to write the state condition here. And that, what I can do is, I want to declare this one. This will help me to detect whether the switch has been pressed once or twice. Now, in this mode equals to state, what I do is, if this condition, when it detects the switch is pressed and this is not equals to, it means what? This statement means when I press the switch 1, it get detected and this is not equals to the release, means it has been detected that the switch has been pressed now, and this should be equals to one condition, that is, it detects that the press has been pressed only once. I think you got clear. The switch has been detected and this is not equals to the released button, and only once it has been triggered. At this time, the once should become 0 so that it should not come again in this loop, and we need to return the same condition, that which switch has been pressed. And next, else if this GPIO pin, when it gets detected, now equals to all released, at that time it should return, no, then just one should make it 1. Now you can see how it works. I will show you the state trigger. Initially, just think the first time when the switch on is pressed, it gets detected and this condition gets failed and once will be 1. At that time, it returns the SW1 is pressed and this condition gets true and LED get turned on. Now, you are still holding, suppose you think you are still holding the button. It comes again to this condition. GPIO is, this condition becomes true, but this condition gets false. At that time, this condition also will be false. On that time, what we need to do is just return all release. At the next, it get all released. This condition gets failed, so this condition does not execute. And when you press the switch again, the second time, there will be a gap of releasing. At that time, this instruction will be executed and once will be 1 and will be waiting for the condition to get turned on here. So this is how the state trigger will work for you. Now let's build this and check. Here you can see the program has been loaded successfully. In the end, you will find the operation, how it is working. Thank you, and if you like the video and the concept, please subscribe my channel. In the upcoming days, you will be getting more about the STM. Thank you.